So here we need to determine the magnitude of the interior angle, and we need to express it in both radians as well as degrees for the following regular polygons. Let us begin with the first polygon, a pentagon. But before continuing with the polygon, let's state few properties. The sum of the interior angles of a irregular polygon with n number of sides is given by the formula n minus 2 times 180 degrees, right? Or if we want in radians, it will be simply multiply with pi radians. Fine. We'll do the conversion after we find out the individual degrees. Now, this is the sum of the interior angles. That's n minus 2 times 180 degree. Since it's a regular polygon, so each angle measure is going to be the same. So that means each angle measure, that is going to be each measure of the angle. This will be simply given by n minus 2 times 180 degrees. We're going to divide by the number of sides. So we're going to use this particular formula. So let's begin with the first one. We have as a pentagon. So how many two sides are there in a pentagon? So that's n value is going to be equals to 5. So that means the angle measure theta, that's going to be 5 minus 2 multiplied to 180 degrees divided by 5. So this comes out to be equals to 108 degrees. So that's the measure of each angle. So now that we have our angle in degrees, we can convert it to radians. All we have to do is multiply the value of 108 with pi over 180. And this is going to convert the theta value to its corresponding radian values. So this comes out to be 3 pi over 5 radians. So the interior angle of a pentagon, so in degrees it's going to be 108 degrees, and in radians it's going to be 3 pi over 5 radians. Okay, let's move on to the second one, which is a heptagon. Now a heptagon, the n value, that's going to be equals to 7, because a heptagon has 7 number of sides. Here n represents the number of sides, of course. So theta value that comes out to be, so we have 7 minus 2 multiplied to 180 degree divided by the total number of sides. So this comes out to be equals to 900 over 7 degrees. 128 4 over 7. So this is going to be in degrees. So we have 128 degrees times 4 over 7 degrees. Now we're going to use the fact that in each degree we have 60 minutes. So for each 4 over 7 degrees, we're going to add 60 times 4 over 7. So that's going to be 240 over 7 minutes. Now 240 over 7 can be also expressed as 34 2 over 7. This is going to be in minutes. So now we have 128 degrees times 34 minutes and 2 over 7 minutes as well. And finally, we're going to convert 2 over 7 minutes to its equivalent seconds. So we have 1 minute equals to 60 seconds. So that means 2 over 7 minutes, that will be 2 times 60 divided by 7. So here we have 120 over 7. 120 over 7, that can be expressed as 17 1 over 7. So here we have 17 seconds. So that means we have 128 degree, 34 minutes and 17 seconds. So this is the angle measure in degrees. Now we also want to express this value in radians. So here we have 900 over 7 degrees. So all we have to do is multiply with pi over 180. So this is going to be 5 pi over 7 radians. Fine. So we have the angle measure of the interior angle of a heptagon, that's 120 degree, 34 minutes and 17 seconds, and in radian measure it's 55 pi over 7 radians. Let's go to the third one, which is an octagon. So we come to an octagon number 3. So we know that the number of sides in an octagon, that corresponds to n equals to 8. So theta measure will be n minus 2 multiplied to 180 degree divided by the total number of sides. Now this is going to be 135 degrees. Now converting degrees to radians, we have 135 times pi divided by 180. So that's simply 3 pi over 4 radians. And then coming to the fourth one, which is a duodecagon. A duodecagon is a regular polygon having 12 sides. So theta will correspond to 12 minus 2 times 180 degree divided by 12. So this will be equals to 150 degrees. And if we want to convert it to radians, so we have 150 multiplied to pi over 180, and this is going to correspond to 5 pi over 6 radian. So here we have successfully converted each of the interior angles of a pentagon. So pentagon comes out to be 108 degree, and in radians is 3 pi over 5 radians. For a heptagon with 7 sides, the interior angle is in degrees comes out to be 128 degree, 34 minutes 17 seconds, and its radian measure is 5 pi over 7 radian. For an octagon, the interior angle in degrees will be 135 degrees with radian 3 pi over 4. And for a duodecagon, the sides having a regular polygon with 12 sides, the internal angle will be 150 degree. Each internal angle is 150 degree, and its equivalent radian measure will be 5 pi over 6 radians.